All right, so we're going to start on 4.2 here, the unit circle and other and trigonometric functions here. Basically, the unit circle is, we're going to define this as a circle with a radius of 1. If you're thinking 1 what, like 1 centimeter, 1 meter, 1 mile, 1 cubit, whatever, it really doesn't matter. Whatever we're measuring in, this has a radius of 1. It's going to have its center at the origin, and it's going to be in the xy plane. And it's going to be the set of points, x and y, that satisfy the equation x squared plus y squared equals 1. And so if you think about the distance formula, it is x squared plus y squared equals z squared, right? Or the Pythagorean theorem for triangles. And basically what we're doing is then that hypotenuse is 1, and we're taking all the points such that our hypotenuse equals 1, would be 1 squared, but that's just 1. And if we take all those possible points, they are going to map out basically a big circle for us that has a radius of 1. And just real quick, I'm going to erase this in a second, but what I'm basically saying is we're going to look at this triangle and take that point, and this triangle and take that point, and all these are right triangles, sorry, here, like that, across there. And this point, and we're going to take every single one of them. I'm not drawing every single one of them, obviously, but all the possible ones, and they're all going to basically land where that corner ends up on the outer edge of this unit circle. Okay, so just so you see what I'm talking about, why it's x squared plus y squared equals 1, plus that's the equation for a circle. The circumference of this unit circle is going to be just 2 pi, because circumference equals 2 pi times r, and here we're making r 1, so this is just a 1, and so it's just 2 pi. We're going to have symmetry over the x-axis. That's like from point P to point Q. We're going to have symmetry over the y-axis, and that could be like point P to point R. And we're going to have symmetry about the origin. Basically, we can rotate it around the origin, and that's P over to S. We can rotate around to there. And we have symmetry over the line y equals x, the identity function, which is P to T. And that was that. That was this line here. I have to actually draw point T in, but we'll have this line. This is y equals x. And then our point T would be something like that. Point T as coordinates y, x, compared to the xy at point P. All right, and basically that's our unit circle, and we're going to use that quite a lot. So let's first start off with finding points on the unit circle. So find all the points on the unit circle whose y-coordinate is 3, 5. So let me draw in a unit circle. Nice and free-handed there, not quite centered at the origin, but that's okay, pretty close. And we want to find all the points where y equals 3, 5. So if we draw in the line, I'm not going to get it exactly here, but if this is 1, this is our unit circle, this is going to be up here at y is 1, this is over here at x is 1. So we're going to go to 3/5, say about right there. And so this is the line, let me draw that a little better. This is the line y equals 3/5. And if we look, it's going to intercept our circle at 2 locations, there and there. And what we want to do is find the coordinates of those places. So this will have some x-coordinate and 3/5 as the y-coordinate for that point. And this one's going to have some other x-coordinate and 3/5 as the y-coordinate. So we want to know what are those 2 numbers that are going to go there. And we can do this by starting with our equation for our unit circle, and basically plug in 3/5 for y. So we'll get x squared plus 3/5 squared equals 1, right? So we plugged in y equals 3/5. That's what we did right there. That gives us x squared plus 9/25 equals 1. X squared equals 1 minus 9/25. And then you need to make them both have the same denominator. So 1 becomes 25 over 25 minus 9/25, which is 16/25, which then that's what x squared equals. And so we take the square root of both sides and we get x equals plus or minus, don't forget the plus or minus, square root of 16/25 is square root of 16 over square root of 25, and that's 4/5. Square root of, or I'm sorry, I shouldn't have the square root there. I took the square root. It's 4/5. That's the square root of 16/25 is 4/5. And so over here, we can say that this is minus 4/5, because we're on the negative side over here on the x-axis. And this one over here is going to be positive 4/5, coming from that right there. Okay, so we got these values to give us these values over here. All right, so not too difficult there. Now let's try this next one. Find all points on the circle whose y-coordinate is -2/3. So we're going to do something similar this time again. That's probably going to have to be redone. Let's draw this circle in. Okay, so there we go. And now what we're going to look at is where y is equal to -2/3. So remember this down here, because this has a radius of 1, this is going to be at y equals -1. Right, so we're down here at -1, which means we need to go 2/3 of the way down. So maybe here-ish. This will be y equals -2/3 right there. And we have two locations where we're actually intercepting it. That's going to be right here and right here. So this will be some point x and then -2/3 for y, and this will be some point x and then -2/3 for y. And so we're going to do the same sort of thing. This one I'll work through a little faster as far as the algebra goes. X squared plus y squared equals 1. And we're going to plug in -2/3. -2/3 for x. And go ahead and square it. X squared plus 4/9, because -2 times -2 is +4. And so x squared equals 1 minus 4/9, which is 9/9 minus 4/9. So this is 5/9. And x is going to equal plus or minus the square root of 5/9. So I can't really do the square root of 5 very well, so I'll leave it a square root of 5, but the square root of 9 is 3. So square root of 5/3 plus or minus it. This is on the negative side, so negative square root of 5/3 and square root of 5/3. Okay, so there is that example. Not too bad there, and if I went too fast there, just rewind it or pause it as I go through and watch it again and make sure you really get that down. So next, trigonometric functions of real numbers. So we're going to let t be a real number, and each real number t corresponds to a unique point p of t on the unit circle and is often called the terminal point associated with t. So we have some point t here, and we're going to basically start looking at what happens if we draw in a triangle here. So we're going to have this, which is a radius of the circle. It's going to be our hypotenuse, and it's going to be r equals 1, because that's the radius of the circle. We're going to have a side opposite of it here. This would basically be how far up we go in the y direction. This will be, we'll call this the opposite side, and it's going to be y, the y value of wherever we ended up with. It'll be this y value right here. We're going to have how far out we go in the x direction. That'll be our x value right here, and we're going to call that our adjacent side, or the x side. And then we're going to have an angle here. And right now we're calling that angle t, so it'll be an angle t. All right, that's what we're putting in for this, is that angle t. And from there, we can define some things based off of this. And there are some more, there's some more better pictures out there than this, just this here right now. But just taking a look at this, we can define the sine. This is called the sine. This first one is called the sine of t. It's an operator that operates on t. It operates on the angle and then tells you a ratio based off this triangle we did up here. And in fact, this one tells you the ratio of the opposite side over the hypotenuse. The opposite side, remember, is y, and the radius is the hypotenuse. In this case, not true for all circles, but here for the unit circle, r is equal to 1. Don't forget, it's a unit circle, so this would just be equal to y. Similarly, we can define the cosine here, right? We can find the cosine of t. That's going to be the adjacent side over the hypotenuse, which will be x over r, which again, r is 1. So in this case, with the unit circle, we get just x. Next, we can define the tangent of that angle, which is actually defined as sine of t over cosine of t, which ultimately gives you the opposite side over the adjacent side, which is just going to be y over x. We can define a cosecant. This is cosecant. This is 1 over the sine of t, which means instead of being y, it's going to be 1 over y. We can have the secant, which is the reciprocal of the cosine, 1 over cosine, which will just give us 1 over x. And then we can have cotangent, which will equal 1 over tangent of t, which will just be cosine t over sine t. Now, each of these things, again, is an operator. It doesn't ever make sense to just have sine written down somewhere or cosine. It has to actually be operating on something. So make sure you're never accidentally writing something like sine equals 5. That one doesn't make sense. You have to have something there. This isn't going to make sense. It has to actually have something there to operate on. Okay? So don't go writing something like that. You might have to have something like sine of some variable, could even be x equals 5. That kind of a statement will be okay. So it's a machine, it has to operate on something, it has to have something to operate. So make sure you're not just leaving sine, cosines, tangents, all those things written by themselves. All right, and you need to definitely know all these definitions here in this box. You need to know them very well. And I think a lot of people do some name SOHCAHTOA or something like that. I don't really know it, but almost every time I say that, all the students already know it. So make sure you know these relationships here. Next, we're going to look at some identities. These are just basically things that are going to be always be true. First, the reciprocal identities, which we kind of just wrote out on the other page, is secant of t is 1 over the cosine of t. Cosecant of t is 1 over the sine of t. And cotangent of t is 1 over the tangent of t, which again I just did in the previous one. Some more, just so you have them more concisely here. We have tangent of t is sine of t over cosine of t, and cotangent of t is cosine of t over sine of t. All right, so we did those on the previous page, but you got to make sure you know these as well. So I'm taking time to write them here extra. Next, let's try an example. Using definitions to write trigonometric function values. So for the point P of t is 5/13 and -12/13 on the unit circle. That's important. On the unit circle, it means r equals 1. Write all the values of the trigonometric functions at t. So basically what we're going to have is unit circle, right? And we have some point on here, x comma y. Technically, in this case, actually, I'm going to move this. This one is in the negative y direction, so it's probably more like over here. Going to have some x comma y, because we have -12/13. And this here is r. And so what we want to do is try and go through and get all of these things. So first off, cosine of t. That's just going to be picking out the x value, because when you look at this, remember, we make this triangle out of it, right, like that. This is x, this is y, this is r, and r equals 1. That wasn't very good. R equals 1. And so cosine is just x over r. This is where t is going to be. And so it's x over r, but r is 1, so we can just write the answer as x, which is just 5/13. That's how far out in the x direction we went for this coordinate right there. And then, so I guess I could write that this is 5/13 and -12/13. That's what x and y are. Then we want sine of t. That's just going to be the y value. Again, we're just how far down did we go in the y direction? -12/13. Tangent takes a little bit of work, but we have to basically do 5/13 over -12/13. Dividing is multiplying by the reciprocal, so this will be 5, oops, I actually wrote that backwards. Hold on one second. This is -12/13, sorry, it's y over x over 5/13. So this is -12/13. Dividing by 5/13 is multiplying by the reciprocal. The 13s will cancel, and we'll be left with -12/5. So yeah, remember that. This is y over x. Sorry, the first time I wrote x over y. So then we have cosecant of t, which is just going to be the reciprocal of the sine value. So it's going to be the reciprocal of our 12/13. So this will become -13/12. Secant is the reciprocal of cosine, so it's the reciprocal of 5/13 or 13/5. And then cotangent is going to be the reciprocal of tangent, which means it's just going to be -5/12, because we just have to take the reciprocal of that right there. If you didn't have tangent already done, then you could have just done what I started to do accidentally, and that's just do 5/13 divided by -12/13. Okay, so let's take a look at this next one. For the point P of t, 1/3 2√2/3 on the unit circle, write all the values of the trigonometric function. So I'm going to leave this one for you to try, but when you go look at the notes, I'll have it filled out for you so you can take a look there. Okay, but I'm going to leave that one for you to try. So let's try doing example 3, evaluating trigonometric functions. So let's take a look here. Here we're given that t is 0. So that's going to pretty much put us right here. We're going to just have no angle we're going to. And so at t equals 0, we're doing the cosine of 0. And if we look over here at this point, the cosine of 0 is just a 1. That's the x value. It's a 1. We're going to do the sine of 0, and sine is the y value, so that's that other little value over there. That's a 0. Tangent of 0 is just sine over cosine, so that's 0 over 1, which is 0. Secant of 0 is 1 over the cosine, so 1 over 1 is 1. cosecant of 0 is 1 over the sine, which is 1 over 0, which is undefined. And then cotangent of 0 is the reciprocal of tangent, which was 0 over 1, becomes 1 over 0, which is also undefined. So for some of these, we're going to end up with results that just don't work. They break our little cosecant or cotangent or sine or whatever. They break our machines for that. So let me do one more, and then I'll probably leave the last one for you to try before I put the answers in the notes. So this one is t equals 3 pi over 2. Okay, so if we look down here, 3 pi over 2 is over here. And notice our points are 0, negative 1. So cosine of 3 pi over 2, that's going to be just the x value, so that's that 0. Sine of 3 pi over 2, that's going to be the y value, that's negative 1. And then we've got cosine, sine, tangent of 3 pi over 2, that's just going to be negative 1 over 0, which is undefined. And then we're going to have secant, which is 1 over the cosine. So we have to have 1 over 0 again, which is also undefined. We'll have secant, we'll have cosecant, 3 pi over 2, which is going to be the reciprocal of sine, which is 1 over negative 1, which is just negative 1. And then we'll have cotangent of 3 pi over 2, which is going to be 0 over negative 1. It's the reciprocal of tangent, which was negative 1 over 0, which is just going to equal 0. All right? I'm going to leave you with the last one to do, but I'm going to give you this little hint here, even though by the end of this lesson you should kind of know what it means. Here we've got negative 3 pi. So here you have to be careful, because going all the way around the circle once, remember, is 2 pi. So we're going around in negative 2 pi, a negative 2 pi would bring us around the circle once like that, back to here, but then we're going, after we go to that negative 3 pi, we have to go another pi to get to 3 pi, right? So if that helps, you can think of it that way. The other way you can think of it as every half a turn is a pi, so 1 pi, 2 pi, 3 pi. That means we're looking at this point right here when you do those values. So try that one, get it filled out, and again, I'll put it up in the notes for you to check it with. Here, trigonometric function values for t equals pi over 4. So for this, essentially you can go through and you can do some algebra and stuff, but this is going to be one of these things where we're going to ultimately end up memorizing what this coordinate is and ones that are like it. And so for this point right there at pi over 4, which is, a quarter of a half of a term, so pi over 4 is actually an eighth of a term. It turns out that those coordinates there, this is a nice easy one, is square root of 2 over 2. Okay? If you want to see more details on this, I'll probably, draw it out for you and show you the triangle in the notes, but ultimately you have a 45, 45 triangle there, 45, 45, 90, and it just works out that when r equals 1, that those are the lengths of the two sides. Square root of 2 over 2 and square root of 2 over 2. So your cosine here is going to be square root of 2 over 2. Your sine of pi over 4 is going to be square root of 2 over 2. And your tangent, I won't do all the reciprocal ones, but your tangent of pi over 4 is going to be square root of 2 over 2 over square root of 2 over 2, which is just 1. All right? So then after that one, we've got another nice little special case, which is at 30, 60, 90 triangles. And so you can have one like this, 30, 60, 90. And so this is the pi over 6, because 30 degrees is pi over 6. And it turns out our locations there, we're going to end up getting the values of square root of 3 over 2 and 1/2. And you know, I'll go over this a little more later when I talk about the unit circle in its entirety. But basically, this gives us sine of pi over 6 is going to just be that y coordinate, which is 1/2. Cosine of pi over 6 is going to be square root of 3 over 2. And then our tangent of pi over 6 is going to be 1/2 divided by square root of 3 over 2, which will ultimately give you 1 over the square root of 3. All right, but you make this little triangle here, and it'll work out a lot like this 30, 60, 90 triangle there, where a equals 1. Okay, so the next one is pretty much like that, but we can do 60 degrees. And at 60 degrees, we again have a 30, 60, 90 triangle, except this time this is 60 and this one's 30. And so it's going to just reverse our results. Instead of getting square root of 3 over 2 and then 1/2, we're going to get 1/2 then square root of 3 over 2. So it's going to flip it around for us, which means our sine is going to be at pi over 3, which is 60 degrees, is going to be square root of 3 over 2. Our cosine of pi over 3 is going to be 1/2. And our tangent of pi over 3 is going to be square root of 3 over 2, square root of 3 over 2 divided by 1/2, which will ultimately end up being square root of 3. All right, so those are our three main points right there. And then I'm going to stop here, and the next video is going to be just about the unit circle and what you need to know for it going